Hello. So up until now, in Lecture 8 and Lecture 9, we have worked with differential equations of the form dy over dx is equals to f of x and dx over dy is equals to f of y. Now in today's lecture, we are going to work on few problems when a differential equation can be put in the form f of x dx is equals to f of y dy. Then in such a scenario, the solution will be given by integrating both sides. So we have fx dx equals to integration f of y dy plus the constant of integration c. So let's work on a few problems, and that is going to help us understand this particular idea. So here we have a differential equation given by x plus 1 times derivative of y with respect to x as equals to 2xy. So here we can separate the differentials, and we have x plus 1 dy equals to 2xy dx. Now further simplification gives us dy divided by y. So we are dividing both sides by y times x plus 1. So that will give us 2x dx divided by x plus 1. So here we see that if we have 1 over y times dy is equals to 2x over x plus 1 dx. So 1 over y is completely a function of y, and 2x over x plus 1 is completely a function of x. So we can now integrate both sides. So we have integration of 1 over y dy equals to integration of 2x divided by x plus 1 dx. So integration of dy over y will be simply natural log of y, which is equals to 2 times. So here we have x over x plus 1. So x over x plus 1 can be written as x plus 1 minus 1. So here we have added and subtracted 1 in the numerator, divided by x plus 1 times dx. So that will give us 2 times integration of 1 minus 1 over x plus 1 times dx. So this is going to give us 2 times integration of dx minus 2 times integration of dx over x plus 1, which gives us 2 times integration of dx will be x minus 2 times integration of 1 over x plus 1 with respect to x will be natural log of x plus 1 plus the constant of integration c, and this is natural log of y. Hence natural log of y equals to, if we take 2 as the common factor, times x minus natural log of x plus 1 plus the constant of integration c is the required solution to the given differential equation. Thank you.